So this is a short video explaining the red and blue zone concept that we use in a number of our development programs. This is a brain-based model, and one of the things that we should point out at the outset is that the brain is massively more complex than any model that we have to describe the brain. And this is particularly so with the model we use here. It's based on some work by Paul MacLean, originally from the 1960s, updated in the 2000s, based on his triune or tripartite brain, which describes three different zones or layers of the brain. So again, in reality, the brain is way more complex than this. So keep that in mind. And also pay attention to models that are based in evidence and scientific research, neuroscience research. Some of the models that we have in our world available to us to help explain the brain are a little bit pop sciencey and aren't really based in any decent science. Left and right brain model is an example of that. So before we go into the model itself, it's important to point out, besides being complex, the brain is massively expensive to run. And you'll see that as we go forward in the example here. But by and large, the brain consists of 2 to 3% of the body weight, yet uses 20 to 25% of the energy budget, the resource budget that our body has. So this is an expensive organ for us to run. So these are our three regions or domains, if you like, and I'm going to explain those as we go forward. So the Triune Model by Paul MacLean describes three layers. This one here, which we would call the reptilian brain, and this is largely to do with the instinctual, and the limbic is largely and the automatic. Habits, muscle memory, if you like, although there's no memory in muscles, but the ability to remember how to swing a golf club, for instance, balance, they largely sit in this reptilian part of the brain. Above that we have, I'm going to use the red pen again, although you'll see in a second it has some interesting aspects. This is the limbic system. So the limbic system is largely to do with the emotions, with memory, and interestingly, decision making. And you can see here, this is coloured in two different colours here. And this is an important area of the limbic system to point out. This little part of the brain is called the amygdala. And this is, amongst other things, a part of your vigilance system. So when you feel threat, this actually starts to engage with the lower part of the brain, the reptilian brain, and starts to give rise to the biology of stress and of threat and of fear. So this part of the body prepares you to stay alive. It's about survival. So the simplest way of describing this is if you're walking home and you hear footsteps behind you and it's dark and it's at night and it just feels a little spooky and the hair on the back of your neck starts to stand up, this part of the brain is becoming very active. The other way to describe this is if you fear public speaking and someone asks you to stand up and give a short speech without you being prepared, this part of the brain becomes active again and prepares your body as if you are facing some sort of physical danger. And this is a maladaptation in our current world. So our reptilian brain, our limbic brain, and then finally over the top, a relatively paper-thin part of the brain, which is a bit like a napkin or a tablecloth that's been scrunched up to fit inside the skull. This is the cortical part of the brain, and this is to do with thinking and thought. This is rational argument, rationale if you like. Language also lives here amongst other things. And I've run out of room, but I'm going to put executive control just here as well, because there's a very important part of the prefrontal cortex, which is a little bit like the conductor in an orchestra, CEO of an organisation, which connects all the parts of the brain and starts to exercise some conscious control. This prefrontal cortex is also where you live, your personality, your ability to recognize faces, your ability to be empathic. A lot of these higher order functions that we associate with being human are actually in this very, very important prefrontal cortex part of the brain. So this is effectively a summary of function, if you like. So I want to look at the idea of cost before we go in and look at the zones themselves. The cortical part of the brain is very expensive, and by cost I mean it takes a lot of the resources available biologically in the brain for it to work. So therefore we need to be at our best to use this part of the brain well. The limbic part of the brain is far less costly. It runs very, very well subconsciously, if you like. In fact, most of the limbic part of the brain is below consciousness. Consciousness really lives in the cortical part of the brain, and this actually runs quite well without much effort or help. And of course, the reptilian brain is the one that is the least expensive to run. It's about survival. It doesn't really have any level of conscious control over it in its native state. And what this means, this particular column, means that when we're run down, we're low on oxygen, we're low on sugar, we're low on available resources that surround that biology, then we will default to this part of the brain. So again, these lower two parts are where we will fall to if we are tired, run down, sleepy, low on oxygen and hungry. This next column I want to discuss is the availability of language, and this is very important in terms of some of the red zone, blue zone work that we talk about. This part of the brain has language. It's where we hear language, where we interpret what we've heard, and also producing language. It's a very complex brain activity that takes up most of the available bandwidth at the time that we're producing language. However, the limbic system and the reptilian system don't have any availability of this language system. So that means emotions naturally don't have a way of describing. This is why emotions sometimes are difficult to describe. This is why also we have artifacts such as music, art, dance, and other such mechanisms that help us interpret what our emotions are doing. People who have higher order skills are able to use their language to articulate what's happening in their limbic brain. And this is a little bit like having to express yourself in a foreign language. And if you don't have emotional language, if you don't have emotional literacy, then there's a bit of a disconnect between what you're feeling and how you express that feeling. The last area I want to look at is in terms of age development. And it's important to be aware that babies actually are born with this, with these two regions here. So these two regions are relatively active at birth. And as we develop over time, we start to build a sense of awareness of others and the impact of others on us, the impact of our behaviour on others. This is indicative of the cortical brain beginning to come into action. So it really starts to take development in terms of a social awareness and social engagement, the ability to exercise choice and control over behaviour. This all starts to happen roughly before or plus or minus a couple of years around the age of 8 and extends through interestingly in women 18 to 20 and in men maybe 25 to 30, the research is suggesting in terms of the maturation of this part of the brain. Some people might suggest that this doesn't ever really happen, and you may know some people like this. So this part of the brain down below, efficient, memory, decisions, emotions, instinct, automatic, easy to run, no language, starts at birth. This part of the brain up the top here, it's rational thinking, it's language, it's executive control, it's expensive to run, it takes lots of resources, it has language, and it develops, clearly language develops before the age of 8. But in terms of social engagement and some of the higher order thinking aspects of the cortical brain, then this starts to happen at a much later stage.